Hey everyone, Wags here from Eagle Dynamics, and in this video we'll take a tour of the F-16 cockpit. In later videos we'll discuss each area in more functional detail, but this video is designed to provide you a general overview of the Viper cockpit and provide you a good understanding of what is where. The cockpit is divided into 5 general areas: the left console, the left auxiliary console, the instrument panel, the right auxiliary panel, and the right console. I will use these left-to-right flow around the cockpit. Let's get started. First, let's take a look at the left console next to your left leg. Starting from the back and moving forward, here we have the test switch control head, and this includes a fire and overhead detection test button that tests the overheat detection system. This then triggers the overheat caution light and the engine fire eyebrow light. These in turn trigger the master caution light. The pitot tube heat power and test switch allows heating of the data probes when it's set to the on position. When it's set to test, the probe heat caution light flashes after a good test. A test switch for the onboard oxygen generation system, or OBOGS. This will trigger a low oxygen eyebrow light. The emergency power unit, or EPU test switch, that tests the system without using the hydrazine. This is tested after an engine start. An indicator light test button that tests the warning and caution lights, as well as the audio voice messages. The flight control system, pronounced FLICUS, a power test switch for the left and right A, B, C, and D light indicators for the 4 redundant flight control channels. Below it is the FLICUS test power switch that, when held to test, it tests power output to the FLICUS when electrical power is first set to battery. Now, prior to an engine start, you would test the FLICUS first. To the right is the flight control system panel, and as you might imagine, this panel allows you to set manual controls of the F-16's flight control system. Now, normally you don't have to touch these very often, as the Viper's flight control system is highly automated. The digital backup, or DBU switch, selects the FLICUS backup software. If enabled, you'll see a DBU caution light and a HUD warning. This would rarely be used though. The alt flap switch allows manual trailing edge flap engagement rather than automatic schedule in the landing gear handle position. You would use this when you have a flap failure or asymmetric flap setting. The alternate manual TF fly-up switch is for terrain following radar and is not used in the Block 50 Viper. Manual or automatic control of the leading edge flaps is controlled by the leading edge flap switch. This allows leading edge flaps to be controlled by schedule or locked in place. The manual setting might be used if leading edge flaps are stuck, or if you have one of the leading edge flaps stuck and you need to have them both at the same setting. The FLICUS reset switch allows the reset of the FLICUS warning and related lights, and resets the servo and electrical FLICUS system failures. The FLICUS bit switch commands a bit test of the FLICUS when it's weighed on wheels. Running a bit test would run the flight control surface through a test sequence, and it's something you would do during the startup sequence. The switch is magnetically held to the bit position while the bit is running, which lasts about 45 seconds. While running, a green bit light illuminates. Once complete and successful, the light turns off and the switch snaps back to the center position. A red fail light appears if there's a problem encountered during the bit, and failure would be listed in the PFLD fault detection display. Directly inboard of the flight control panel and related is the manual trim panel. Now, under normal flight conditions, you almost never have to touch this panel, as the F-16 does a great job auto trimming and pitch, but you can still trim for pitch and roll using the trim switch on the control stick. In the top left corner of the panel is the roll trim wheel indicator. In the bottom right corner is the pitch trim wheel indicator. In the bottom left corner is the yaw trim dial without indicator. The trim autopilot disconnect switch allows you to disable control stick trim in autopilot mode in case the trim head on the stick malfunctions. Next is the fuel control panel. On the leftmost side is the master fuel switch, which is guarded, and it opens or closes the main fuel shutoff valve. This is normally guarded in the on position. Next to it is the tank inerting switch, which can pump non-volatile nitrogen gas into the fuel tanks to reduce internal pressure and reduce the risk of fire during an emergency, like battle damage. To the right of that is the engine feed knob that energizes or de-energizes the fuel pumps and maintains center of gravity fuel loading. The engine feed dial provides you automatic or manual aircraft fuel balancing. An imbalance is most visible on the fuel gauge and is indicated by a divergence between the two fuel needles. The aft and forward settings allow selective pump control for those tanks with crossfeed. These also allow manual shifting of the center of gravity. The normal position allows fuel system to try to auto balance, and off turns off the fuel pumps. On the right side of the panel is the air refuel switch that opens or closes the air refueling door on the spine of the aircraft behind the canopy. It also sets the flight control gains to the takeoff and landing mode. Inboard of the fuel control panel is the Identify Friend or Foe, or IFF panel. We'll talk about this in a later video. The external lighting control panel controls all externally mounted lights on the aircraft. The anti-collision knob has an off and 7 options that apply to the anti-collision lights when in flashing mode, 1 to 4 and A to C, and these vary in their flash patterns. The flash and steady switch toggles the position lights between flashing and steady modes. Both the wingtail and fuselage switches have 3 positions that can be set to bright, off, and dimmed. In the bottom left corner of the panel is the formation lights knob that controls the brightness of the formation lights. To the right of this is the master covert knob that has positions to determine the flash pattern and the brightness of the external lights. Now finally, there's the air refueling door light that sets the brightness of the light that shines on the refueling receptacle so that the air refueling boom operator can identify the receptacle during nighttime refueling operations. Next, let's take a look at the EP, or the Emergency Power Unit panel. This is a hydrazine-powered self-contained unit that can provide emergency hydraulic and electrical power when just bleed air is not enough for about 10 to 15 minutes. You most often use this if you lose an engine, and the EP would provide power to the hydraulic and electrical systems. And in a way, it's like a very limited auxiliary power unit, or APU. At the bottom of the panel is a guarded EPU switch. In the normal position, it operates automatically when the conditions demand, like the loss of hydraulic systems and/or both the main and standby generators. But it can also be manually used in the on position. When the EPU is running and within the proper turbine range, the EPU run light illuminates. The air light illuminates when the EPU is engaged and running on air and not hydrazine, and the hydrazine light is lit when the hydrazine is used to power the turbine. The electrical panel selects the electrical power source for the aircraft. From the power switch, you can select main power that connects external power or the main generators to the electrical system. Battery connects the battery to the battery bus, and off disables electrical power. When starting the aircraft, you would first place a switch to battery power to run test, and after that, place a switch to main power for engine start. Below the switch is the electrical caution reset button that can clear electrical caution lights and reset the main and standby generators. On the right side of the panel are a series of lights that include an amber main generator light when there's no external or main generator power, an amber standby generator light that indicates that the standby generator power is not available, an amber EPU generator light that the EPU is running but not providing power to both emergency buses, and an amber EPU permanent magnet generator that indicates the EPU has been turned on, but there's not enough power from the PMG to power all branches of the FLICUS. Along the bottom of the panel are the aircraft battery indicator lights. The fail light comes on if there's less than 20 volts in the battery when airborne or battery failure on the ground. TO FLICUS light illuminates. It means that one or more branches is getting less than 25 volts while airborne, or battery power is going to one or more FLICUS branches while on the ground. And the FLICUS relay will illuminate if one or more FLICUS branches is getting less than 20 volts, or one or more are not connected to the battery. Right of the electrical panel is electronic countermeasures, or ECM panel. We'll talk about this panel later in the defensive systems video. Below that is the airborne video tape recorder, or AVTR, that records HUD and MFDs, or helmet and MFDs, depending on the setting. As the name implies, the engine and jet starter control panel governs the starter for the GE129 engine and related controls. At the top of the panel is a jet fuel starter switch with off and start 1 and start 2 positions that use one of 2 brake and jet fuel starter accumulators to drive the hydraulic starter motor. Using JP8 fuel, starter 2 should be used. Next to the switch is a JFS run light that illuminates within 30 seconds after JFS initiation. Below is the guarded switch for the primary and secondary engine control modes. You normally have this in primary mode unless you run into a failure with the engine's digital electric control, in which case you can select secondary mode, or you'll have to cycle the engine to restart it after a flameout. Note that in secondary mode you have no afterburner. Also in secondary mode, the cycle light will illuminate on the caution panel and you'll have a higher thrust at idle power. Below that is the AB reset switch, and detailed engine parameters can be recorded. The max power switch at the bottom of the panel is inoperative and not used in the 129 engine. While most of your radio use will be through the Integrated Control Panel, or ICP, and the Data Entry Display, or DED, on the instrument panel, a backup UHF radio head is also available and must be used before engine start, as it's the sole radio that functions only on battery power. For those familiar with our 810C, this is the exact same UHF radio. This includes a door with a preset channel entry button behind it with the selected preset channel to the right of the door. To the right of that is a knob that selects the preset channel. In the center of the panel are controls to set the frequency with input dials and a display window. Along the bottom is a function knob to control radio power and mode, a tone signal button, the volume knob, squelch select, a mode select knob for manual, and preset guard frequency of 243 MHz. The Audio 1 panel controls power and volume to both radios, COM1 and COM2, and both radios have settings to disable squelch, enable squelch, and guard settings. On the right side of the panel are controls for secure voice volume, Sidewinder seeker volume, audio threat volume, and a TF tone knob, which is not functional in the Railjet. Just below the Audio 1 control panel is the control panel for Audio 2, and this includes an intercom volume knob for communications with the ground crew and boom operator, as well as a TACAN code volume knob, instrumented landing system or ILS power and localizer identification signal volume, and a hot mic switch. The throttle moves in an arc with aft and forward providing thrust. Fully aft, the throttle is in the off position, but then moves to idle when we move forward over the hump. Moving the throttle forward over the next hump engages dry military thrust. Moving over that hump then engages the afterburner. The throttle is one element of the hands-on throttle and stick, or HOTAS control system. HOTAS functions at the throttle include radio transmit switches, IFF interrogation control, a manual range and uncaged knob, radar antenna elevation, control wheel, a dogfight switch, as well as a speed brake and radar control cursor. In case of a deep stall departure, the pitch override switch allows you to command greater authority from the stabs to help to get the nose pointed downhill so you can gain speed for control flight. The guards on either side of the switch allow the pilot to better grip it in case of inverted departure when he's hanging upside down by the straps. Between the left console and the ejection seat are several more elements. The ejection seat arming handle must be in the down and aft position for the seat to be armed and allow ejection. You would not arm the seat until you're at the hole short before taking the runway, and disarm it upward to forward once you clear the runway after landing. Moving the seat harness lock forward locks the ejection straps over the pilot and would be used for an arrested landing to keep the pilot from being flung too far forward. On the side of the ejection seat is an emergency oxygen bottle. To use this oxygen supply, the lever is pulled. Along the left wall are several more controls. Often called the spider guard, it clamps the canopy down to avoid any possibility of opening in flight. It also guards the canopy switch. With the canopy closed, the spider guard is flush against the wall and the canopy is down and locked. If the guard is not down, you'll get the canopy eyebrow light. In case of emergency, you can pull the canopy jettison handle. This would be used if the primary ejection handle is pulled, but the canopy fails to separate from the aircraft, preventing ejection. The defog lever can be forward and back to provide defogging of the canopy. As a last resort to popping off the canopy before ejecting, a manual canopy crank is also available. This would only be used if the primary and emergency ejection handles fail to separate the canopy. Now, moving forward, the left console is the left auxiliary panel, and the bottom half is dominated by the countermeasure portions, or the CMDS, but another large element is the landing gear handle and button. Now, we'll talk about the CMDS in a later video regarding defensive systems, but other elements of the left auxiliary panel include the following. Much like the GHEMIX of the Hornet, the helmet-mounted cueing system of the F-16 uses a very similar system. This allows flight and weapons cue information to be displayed on the helmet visor. Rotating the knob allows you to turn it off and on, as well as adjust the brightness. The alternate landing gear release handle lowers the landing gear in case of a hydraulic failure or the inability to lower the main landing gear handle. The speed brake indicator has three possible indications: closed, open, and no power. When closed, the indicator displays closed. When it's open, it has a series of 9 dots, and when it has no power, it has striped lines. The store's configuration switch has positions for Cat 1 and Cat 3. This generally translates to Cat 1 being for air-to-air loadouts, and Cat 3 for being heavier air-to-ground loadouts or lots of gas under the wings. When set to Cat 3, the flickus limits the angle of attack and onset rates to increase the departure resistance. The landing gear horn silence button allows you to turn off the audio horn when you get below 190 knots, below 10,000 feet, flaps are extended, and the landing gear is not down and locked. Now this generally warns you to lower the landing gear, but you may also hear it if you get really slow in a dogfight below 10,000 feet. The landing and taxi light switch allows you to set this light for landing and taxi operations. The downlock override button allows you to raise the landing gear with weight on wheels. Maid tendons would be a prime example. Related, the ground jettison switch will allow you to release freefall bombs with weight on wheels. The brake switch can be set to anti-skid or parking brake modes. You can also turn it off, of course, too. Note that the parking brake does not use hydraulics, but rather a clamping mechanism which requires battery power to initiate. The tow brakes can be initiated by either electric channel 1 or 2, which both operate the hydraulic valves. You normally keep the set to channel 1. The emergency jettison switch will dump fuel tanks, carded suspension racks, as well as free fall ordnance. The landing gear position lights show the state of the mains and the nose wheel. When green, the gear is down and locked. When the landing gear is in transit, the landing gear handle will shine red, and when the nose and the mains are in the commanded position by the handle, the light will turn off. And finally, we have the emergency arrestor hook. And no, this is not meant to be laying on carriers, although I know many of you will try. Note that once the pilot drops the hook, it cannot be retracted by him all the way. The ground crew will have to do that. Let's now move to the left side of the instrument panel. The two autopilot switches allow you to set pitch and roll. The pitch switch can be set to altitude hold to maintain the current altitude. Autopilot offsetting turns it off, and attitude hold sets the aircraft to maintain its current pitch and roll attitude. The roll switch includes a heading select setting to have the aircraft turn to and maintain the heading select bug on the HSI. Attitude hold maintains the current roll and pitch attitude, and steering select directs the autopilot to steer to the selected steer point as selected from the DED. Both switches can be used in unison. The terrain avoidance button here is for terrain following radar, but is not used in the Block 50 Viper. The master arm switch has 3 positions, and in the off position, ordnance release is prohibited except for emergency jettison. In arm and simulate, the radar and stores management system operate normally, but no ordnance can be released in simulate. The alt release button functions as a backup to the weapon release button on the control stick in case of a malfunction. If a targeting pod is loaded, the laser arm switch will arm the laser. When electronic countermeasures are transmitting, the ECM light will illuminate. The radio frequency or RF switch is a 3-position switch that allows you to control emissions from the aircraft. When set to silent, all electronic signals from the aircraft are disabled and include radar, radar altimeter, data link, TACAN transmit, and ECM. In quiet mode though, the radar and TACAN transmit, but all other emissions are inhibited. The ALR56M Threat Warning Azimuth Indicator is the Radar 1 receiver scope in the Viper. It is a planform design in which your aircraft is in the center and the emitters are detected 360 degrees around it. To the left of the scope are the threat warning indicator lights. We'll talk about this in the countermeasure systems in a later video about the Viper's defensive systems. Along the top left side of the instrument panel are another set of lights. These include the following. Pressing the IFF identification button initiates an IFF response to an interrogation or request from air traffic control. When a fault appears on the Pilot Fault List Display, or PFLD, the Fault Acknowledge button is pressed to clear the fault. The Master Caution light will illuminate anytime a warning light is lit to indicate a malfunction or a specific condition has occurred. It does not illuminate with a caution light. It can be reset by pressing the light button. Let's now shift our view to the top of the instrument panel. The angle of attack indexer consists of 3 lights. If the top light is illuminated with a red chevron, you are above 14 degrees angle of attack and you're pulling with an energy depleting angle of attack. If the center green circle is illuminated, your angle of attack is between 11 and 13 degrees and you're on speed with optimal angle of attack. And if the lower light with the amber chevron is illuminated, your angle of attack is below 11 degrees and you're energy gaining with an angle of attack that is less than optimal. This is duplicated on the angle of attack gauge on the instrument panel and the angle of attack bracket on the HUD, which is only visible when the landing gear is down. When landing, you should be shooting for between 11 and 13 degrees of angle of attack, and also note that these lights are always on, not just when the gear is down. The center light of the nose wheel steering and air refueling door light illuminates green NWS when nose wheel steering is engaged. When engaged, rudder pedal movement allows steering of the nose wheel. When doing air refueling, the top light is blue and indicates the door is open and ready. The middle AR light is green when the refueling boom is latched on, and the bottom disconnect light is displayed when a disconnect occurs. Moving down, we have the center portion of the instrument panel. The Integrated Control Panel, or ICP, fills the top portion of the center instrument panel and is one of the core systems of the Communications, Navigations, and IFF, or CNI, in the Viper. We'll talk about specific functions in later videos, but an overview of the functions include the following: Radio 1 and 2 control buttons, the Identify Friend or Foe button, the list option that displays options on the Data Entry Display, or DED, select either air-to-air or air-to-ground master modes, wheels to control brightness, symbology brightness, reticle depression, and raster contrast. The raster selection is not applicable to this F16 version. A keypad that also serves as shortcuts to the DED functions. A FLIR video controls, an increment and decrement switch, the data control switch, or DCS, and no, I didn't make that up. This is also called a Dauber switch, and I have no idea why. The drift cutout switch, or warning reset switch. The warning reset is used to clear warnings that are not present on the caution panel or the PFLD, but rather on the HUD and the audio. And finally, we have our recall button. The airspeed and Mach indicator is pneumatically powered by the pitot-static system. Airspeed is indicated by the outside gauge and pointer between 80 and 850 knots, and Mach is indicated by the window near the top of the indicator between 0.5 and 2.2 Mach. The red triangle in the indicator indicates the VNE, or velocity never exceed, and the green triangle can be set by the knob. The altimeter is servo-pneumatic and can indicate altitudes between -1,000 to +80,000 feet. It has both a primary electrically powered mode and a secondary pneumatic mode. If in secondary mode, the pneumatic flag appears on the gauge to indicate pneumatic mode. The barometric setting allows you to input the desired altitude setting as indicated by the small window to the right of the digital altimeter window. The angle of attack indexer duplicates the same information as on the angle of attack indexer next to the HUD, but it ranges between -32 and +32 degrees. The tape is colored to match the indexer lights next to the HUD. The bar in the center of the tape indicates your current angle of attack in relation to the center of the tape. The Attitude Director Indicator, or ADI, displays the aircraft's pitch and roll attitude as supplied by the Inertial Navigation System, or INS. The indicator also includes a turn rate needle that the needle's width equates to 1 to 1.2 degrees per second, and a ball and slip indicator. The pitch trim knob can be used to adjust the sphere in relation to the aircraft symbol. When the instrument landing system is enabled, the ADI can also display the localizer and glide slope bars along with associated warning flags. We'll talk about this later in an ILS video. The vertical velocity indicator, or VVI, displays a rate of climb or descent on a moving tape with a range of 6,000 feet per minute in climb or dive. The horizontal situation indicator, or HSI, displays a plan view of the aircraft in the center of the display. The compass around the aircraft display is driven by the INS system, so that magnetic north is always red at the lubber line. The heading set knob allows you to set the heading indicator, and the course knob allows you to set the course. We'll talk more about the HSI in the upcoming navigation video. In the real aircraft, the pedal adjustment handle allows the pilot to adjust the distance to the rudder pedals. The Fuel Quantity Select panel allows you to determine what fuel information is displayed on the fuel gauge. Test will place both pointers at 2,000 pounds and the totalizer at 6,000 pounds. In norm, the AL pointer indicates remaining fuel in the aft left reservoir in the A1 fuselage tank, and the FR pointer indicates the sum of fuel in the forward right reservoir tank in the F1 and F2 fuselage tanks. Reservoir moves the AF and FR pointers to display fuel in the aft and forward reservoir tanks. Interior wing indicates the interior left and right external fuel tanks. Exterior wing indicates the fuel load in exterior external fuel tanks. The FR pointer indicates the center fuel tank load when set to exterior center. The external fuel transfer switch allows you to transfer fuel first to the center tank and then the wing tanks in the norm position, or to the wing tanks and then the center tank in the wing first position. The pull to eject handle is located in front of the seat, and when pulled, it jettisons the canopy and then starts the seat ejection sequence. Moving to the right, we now have the right side of the instrument panel. The Data Entry Display, or DED, provides display of communication, navigation aids, identification, term CNI, and weapon delivery related information. Manipulation of the DED is done through the ICP. The standby attitude indicator is a self-contained, electrically powered vertical gyroscope that positions the sphere to indicate aircraft pitch and roll attitude. You can cage the SEI to level pitch and roll by pulling the cage knob. The fuel flow indicator is a digital indication of the amount of fuel being burned by the engines in pounds per hour. The indicator ranges from 0 to 80,000. The right multifunction display, or MFD, is identical to the one on the left side. Along the right eyebrow are a series of split emergency lights that often require immediate action if illuminated. The engine light will illuminate when RPM or FTIT indicator signals indicate an overtemperature, flameout, or stagnation has occurred. This means an RPM of less than 60% or an FTIT of 1000 Celsius or more. The engine light will illuminate if fire is detected in the engine bay. Both the hydraulic and oil pressure lights will illuminate if the oil pressure falls below 10 psi for more than 30 seconds, or if either the A or B hydraulic systems is below 1000 psi. The FLICUS warning lights illuminate if a malfunction is detected in the FLICUS processors, power supplies, input command or sensors, angle of attack, or air data inputs. It will also illuminate if leading edge flaps are locked or the built-in test fails. The DBU light will illuminate if the FLICUS digital backup is enabled. The takeoff and landing configuration light illuminates if the landing gear is not down and the aircraft is below 10,000 feet, the airspeed is less than 190 knots, and the descent rate is greater than 200 feet per minute. It will also correspond to the landing gear intermediate horn sound. The canopy light is lit when the canopy is not down and locked, and the low oxygen light will illuminate if the oxygen system is below 5 psi or there's a bit test failure. The engine is equipped with a self-contained oil system to lubricate the engine and the gearbox. The indicator reads between 0 and 100 psi. The normal idle throttle psi on the ground is about 15, and at military power and above about 60. The engine nozzle is variable and consists of two sections. The divergent nozzle moves freely in conjunction with the convergent nozzle. The convergent nozzle is actuated by 4 hydraulic actuators, and the percentage of the nozzle opened is indicated by this gauge. The RPM indicator indicates engine RPM is supplied by the engine alternator, and is expressed as a percentage value from 1 to 110. Note that the speakers still go to 11. The fan turbine inlet temperature, or FTIT, indicates the average temperature in degrees Celsius, and it can range from 200 to 1200 degrees in increments of 100. Moving down to the right is the right auxiliary panel. The magnetic compass is a self-contained indicator which shows the heading of the aircraft in relation to magnetic north. The fuel gauge displays total remaining fuel in the digital window in pounds of fuel, and the 2 needles indicate fuel in the aft and left, and forward and right. If the 2 needles become too divergent, indicating a fuel imbalance, then red will be showed at the base of one of the needles. In such a case, you would then use the engine feed switch on the fuel panel to correct the imbalance using the aft and forward settings. The pilot fault list display, or PFLD, lists all FLICUS detected faults. 2 types of PFLDs are listed: warning level and caution level. Warning level are associated with FLICUS and have a bracket around them. Cautions are associated with other FLICUS elements, engines, and avionics systems. When a PFLD item is displayed, its corresponding caution light indicator will illuminate, and the master caution light will be lit. To clear a PFLD fault, the fault acknowledge button is pressed. The hydraulic pressure in the A and B systems are indicated on the 2 gauges here. Normal operation is between 2,850 and 3,250 psi. The caution light panel consists of multiple lights associated with possible detected fault conditions. Most of these can be reset by pressing the master caution light, but FLICUS, engine, avionics caution lights can be reset by pressing the fault acknowledge button. The electrical caution light, though, must be reset by the electrical caution reset button on the electrical panel. A FLICUS caution must also be reset by pressing the FLICUS reset button on the FLICUS control panel. The EPU quantity indication shows the remaining supply of hydrazine as a percentage. At 100%, the EPU can run for about 10 to 15 minutes. The cockpit air pressure altimeter indicates the air pressure in the cockpit. The clock is an 8-day manually wound clock with the provision of elapsed time up to 60 minutes. Moving down, we find ourselves at the right console. The F-16 is quite unique for its time when it included a force sensing stick that uses transducers for both pitch and roll to determine flight inputs based on G and angle of attack. Despite being a force sensing stick, the stick still moves 1/8 of an inch in both axes, providing more natural feedback. Maximum pitch commands are generated with 25 pounds of force, and a maximum roll command is 17 pounds of force. However, in takeoff and landing, as well as aerial configuration, flick gains for maximum roll are reduced to 12 pounds. Behind the stick are wrist and armrest assemblies. The stick is packed with hats, buttons, and levers that keep your hands on the stick when in the heat of combat. The sensor power control panel consists of 4 switches. They are all power switches on and off to control power to the chin pod stations, the fire control radar, or FCR, and the radar altimeter. As the name implies, the HUD control panel determines how and what information is displayed to the heads-up display. The panel consists of 8 switches. First is the scale switch. When set to VV/VAH, the vertical velocity scale, altitude scale, and the heading taper are displayed. When set to VAH, all the scales are displayed except for the vertical velocity scale. Off removes all scales but the digital readouts. The flight path marker switch, when set to ATT/FPM, displays both the flight path marker and the attitude reference bars. When set to FPM, it just displays the flight path marker. Off removes both. The DED and PFLD switch allows data from these displays to be visible on the HUD based on DED or PFLD selection. Now, off displays neither. The depressed reticle switch controls selection of the primary or secondary standby reticle on the HUD. Standby displays the standby reticle and removes all other HUD symbology. Primary displays the primary reticle but does not remove any HUD symbology. Off does not display either reticle. The airspeed switch allows the airspeed to display as calibrated airspeed, true airspeed, or ground speed. The altimeter switch allows the altitude tape to indicate radar altitude, barometric altitude, or automatic. When set to automatic, radar altitude displayed when the height above ground is less than 1,500 feet, and barometric altitude is shown when above. The HUD brightness switch has default settings for day and night, and an auto brightness function that will adjust accordingly. And last, we have the HUD test switch. When set to on, it will display a test pattern, or when set to step, it will display hash marks to set up your best seat to eye position. The interior lighting panel consists of 3 knobs to turn on and control brightness in the cockpit. Most of the lighting is green to support night vision goggles. The primary consoles knob controls lighting of the left and right consoles. Primary instrument panel knob sets the lighting of the instrument panels and auxiliary panels. The primary data entry display knob controls lighting of the DED and PFLD displays. The malfunction indicator light switch sets the AOA indexer, nose wheel steering, and air refueling lights, the DED, ECM control panel, MFDs, and PFLD, as well as the threat warning systems to either dim or bright. The flood instrument knob controls floodlight intensity on the instrument panel, and the flood console knob controls floodlight intensity on the left and right consoles. The environmental control system panel is split between setting the cockpit temperature and setting the bleed air source. The temperature control has really no function in the simulation, but the air source knob has options to close the bleed air valves. Normal sets the ECS for automatic operations. Dump equalizes the air pressure to the outside air pressure, and RAM closes the bleed air valves and dumps the cockpit pressure. In an emergency, like a crash in enemy territory, the zero eye switch can be used to erase all sensitive data from the systems, like GPS keys, secure voice, and others. The voice message switch has an inhibit setting to turn off all voice messages. Between the right console and the ejection seat is the emergency manual chute handle. This would be used if the pilot does not automatically separate from the ejection seat and it deploys the seat kit. The oxygen regulation panel controls the flow of oxygen to the face mask. The supply lever enables the system to be off, supply air in the on setting, or it also includes a pressure breathing for G with the PBG setting. The dilute lever can be set to normal O2 mixture or 100% O2. The emergency lever can set to system between emergency, normal, and a mask test. At the top of the panel is a gauge to indicate the PSI in the O2 system. The secure voice panel is something we hope to implement at a later point once we add integrated voice over IP into DCS World. The anti-ice system prevents ice buildup on the probes and in the engine. It is activated by placing the switch in the on position, but it will also be set to the automatic and will automatically turn on when ice is detected. Off disables the system. The 2 switches of the antenna select panel allow you to select the upper, both, or lower antennas for the IFF and UHF radios. The avionics power control panel has the following functions. First, power to the modular mission computer, the MMC. Then we have power to the store stations, or STA. Then power to the 2 MFDs. Power to the upfront controls, or UFC. There's also a map power, but it's not really implemented in the Block 50 Viper. Then we have power to the GPS receiver. power to the data link, or DL. And then we have the inertial navigation system knob, or INS, and this has selections for both stored and normal alignment, normal INS navigation, in-flight alignment, and an attitude alignment that allows you to fly along a set course and then have the GPS update the INS. And then last we have the multifunctional information distribution system, or MIDS, that allows you to turn the data link on and off. The seat height adjustment switch can be used to raise or lower the height of the seat for the best field of view of the HUD, and this would be used in conjunction with the HUD step option on the HUD control panel. And this concludes this tour of the DCS F-16C Viper cockpit. I very much hope you enjoyed it, and I'll see you next time. Thanks.